So first topic is line integral. Line integral, it consists only single integral. So this definition is f of z be a function of complex variable. So complex variable means z equal to x plus iy and dz equal to dx plus I into dy. So complex function is f of z that equal to u of xy plus I into v of x comma y. So x comma y are two variables. Then integral over c f of z dz equal to integral. So then we taking the limits a to b. F of z is u plus iv and dz is dx plus I dy. So this is also called contour integral. Next, problems on line integral. First one is evaluate integral 0 to 3 plus I z square dz along the line x equal to 2y. So solution is first to write given line equation x equal to 2y and let z equal to x plus iy. So to evaluate integral 0 to 3 plus I z square dz, that is, so to solve the integration, this is the line integral. That means it consists of only single integral. So given limits 0 to 3 plus I, these limits are in the form of x plus iy. Here lower limit is 0. That means 0 plus I into 0. Here lower limit x equal to 0 and y equal to 0. Upper limit is in the form of x plus iy. So x equal to 3 and y equal to 1. That equal to integral. So the limits are 0, 0 to 3, 1. Z square. Z square means x plus iy whole square and multiple of dz means dx plus I dy. So that equal to, this is the line integral means only single integral. So we change into the variables in single variable. In that way we have to substitute x equal
అది
to 1.
దివ్య ఈ సైట్ గురించి
So
చెప్పినట్టు
integral
చదువుతున్నారా లేదు
0 to 1, that means the integration it may be changed into single variable y. So let x equal to 2y plus iy whole square into dx equal to 2 into dy plus
అవును
I into
ఎందుకంటే
dy.
ఒక్కసారి
Then
నాకు
we are
నువ్వే
taking the
కన్ఫ్యూజ్
limits
నువ్వేదో అమ్మారా
y.
ఇక్కడ కన్ఫ్యూజ్
మ్యూట్ లో పెట్టండి.
ఇంకా వీళ్ళు
limits 0 to 1, that equal to integral 0 to 1 a plus b whole square is 2y square, 2y whole square, that means 4y square plus I square y square plus 2ab, that means 4i y square, and multiple of dy is a common value, a multiple of 2 plus I. So that equal to 2 plus I is constant. So then to write 2 plus I without integration, integral 0 to 1 4y square minus y square plus 4i y square dy, that equal to 2 plus I integral 0 to 1 4y square minus y square is 3y square plus 4i y square of dy, that equal to 2 plus I into, then separate the two integrals, integral 0 to 1 3y square dy plus 4i is constant, 4i integral 0 to 1 y square dy, that equal to 2 plus I multiple of 3 into y square integration is y cube by 3 with the limits 0 to 1 plus 4i into y square integration is y square by 3 with the limits 0 to 1, that equal to 2 plus I into, then substitute upper limit is 1 and lower limit is 0, then we get y cube, that means 1 cube minus 0 cube plus 4i by 3 into 1 cube minus 0 cube, that equal to, finally we get 2 plus I into 1 plus 4i by 3. Next problem is evaluate integral 2y plus x square dx plus 3x minus y dy along the parabola x equal to 2t and y equal to t square plus 3 joining the points 0, 3 and 2, 4. Differentiation is 2t dt plus 3 is 0. So to evaluate integral 2y plus x square dx plus 3x minus y dy that equal to, so given x and y variables are changed into single variable t. So this integration may be changed into t variable. Then substitute x equal to 2t and y equal to t square plus 3, dx equal to 2 dt, dy equal to 2t dt. Then the integration becomes integral 2 into y is t square plus 3 plus x square means 2t whole square into dx is 2 dt plus 3 into x is 2t minus y is t square plus 3 multiple of dy is 2t dt. So that equal to, after multiplication, integral 2t square plus 6 plus 4t square multiple of 2 dt plus second term is 6t minus t square minus 3 multiple of 2t dt. So that equal to integral, in first term is 6t square plus 6 into 2. That means integral 12t square plus 12 plus, in second term, 12t square minus 2 cube minus 60 into dt. So in this integration, we want the limits, t limits. So already given points are 0, 3 and 2, 4. These limits are x varies from 0 to 2 and y varies from 3 to 4. So given equation is x equal to 2t, which implies t is x by 2. Already given that x limits are 0 to 2, then t limits are, then substitute x equal to 0, which implies t equal to 0 and x equal to 2 and t equal to 1. So that's why t limits are 0 to 1. Then substitute the t limits 0 to 1. Adding that values 24t square minus 2t cube minus 60 plus 12 into dt. Then separate the 4 terms. First term is 24 into t square integration is t cube by 3 minus 2 into t power 4 by 4 minus 6 into t square by 2 plus 12 into t with the limits 0 to 1. So that equal, then substitute upper limit is 1 and lower limit is 0. Finally, we get answer is 33 by 2. Evaluate integral 0 to 2 plus I z square dz along. First one is the real axis to 2 and then vertically to 2 plus I. Second one is the imaginary axis to I and then horizontally to 2 plus I. So solution is to evaluate integral 0 to 2 plus I z square dz. So first one is the along the real axis to 2 and then vertically to 2 plus I. So to see the figure, in this figure, along the real axis to 2 means, real axis means x axis, to 2 means x value is 2 and y value is 0. Then let that point is to say A, and then vertically to 2 plus I. 2 plus I means this is in the form of x plus I. Here x is 2 and y is 1. So vertically means this is the parallel to the y axis. So to evaluate along OA. Therefore O is, that means origin, O equal to 0, 0 and A equal to 2, 0. So in these 2 points, then y value is 0, which implies dy equal to 0 and x limits are 0 to 2. First to evaluate along OA, next to evaluate along AB, finally adding 2 values. So first to evaluate along OA. So integral 0 to 2 plus I z square dz equal to integral. In this line along OA, we have to take the limits x 0 to 2 and z square means x plus iy whole square, dz is dx plus I dy. So that equal to integral 0 to 2 x plus iy whole square means x square minus y square plus 2ixy and multiple of dx plus I dy, that equal to integral 0 to 2 along OA means then we take y equal to 0 and dy equal to 0. Then these values substitute in this integration, we get integral 0 to 2 x square dx. So that integration is x cube by 3. So with the limits 0 to 2, then substitute upper limit is 2 and lower limit is 0, that equal to 8 by 3. Next, to evaluate along AB. So A is 2 comma 0 and B is 2 comma 1. So in this AB we get x equal to 2 and dx equal to 0. So y limits are 0 to 1. So to evaluate integral 0 to 2 plus I z, z square dz equal to integral y equal to 0 to 1. These are y limits. And z square is x plus iy whole square, dz is dx plus I dy. So integral 0 to 1. The expansion of x plus iy whole square is x square minus y square plus 2ixy into dx plus I dy. Then substitute x equal to 2 and dx is 0. We get integral 0 to 1 4 minus y square plus 4y multiple of I dy. Then multiple with I, that equal to integral 0 to 1 4i minus iy square minus 4y dy. Then integrate three terms. First term is 4i, integration is y with the limit 0 to 1 minus I into y square, integration is y cube by 3 minus 4 into y square by 2 with the limit 0 to 1. Then substitute upper limit 1 and lower limit 0, that equal to 4i minus I by 3 minus 2. So this is along AB. Finally, we get the answer is integral 0 to 2 plus I z square dz equal to adding along OA and AB. OA is 8 by 3 plus along AB is 4i minus I by 3 minus 2, that equal to 11i by 3 minus 2. Along OA is 8 by 3, along AB is 11i by 3 minus 2. So finally along the real axis to vertically to 2 plus I is integral 0 to 2 plus I z square dz equal to 8 by 3 plus 11i by 3 minus 2. So that equal to 2 plus 11i by 3. So this is the real axis to 2 and then vertically to 2 plus I. Next, to find along the imaginary axis to I and then horizontally to 2 plus I. So in this figure 0 1 is along imaginary axis means y axis. So y axis, that means the point is x 0 and y is 1, and then horizontally means this is parallel to the x axis 2 plus I. 2 plus I means this is in the form of x plus iy. So here x is 2 and y is 1. First to find OP and next to find PQ, then finally adding two values, then we get the final answer. First to find along OP, then points are O is origin 0 0 and P equal to 0 1. So in these 2 points x is 0 and which implies dx equal to 0. So y limits are 0 to 1. First to find integral along OP means integral 0 to 2 plus I z square dz equal to integral z square means x plus iy whole square into dz is dx plus I dy, that equal to y limits 0 to 1. Then the expansion of x plus iy whole square is x square minus y square plus 2ixy multiple of dx plus I dy, that equal to, then substitute x0 and dx is 0. We get minus I integral 0 to 1 y square dy. That integration is y cube by 3 0 to 1. Finally we get minus I by 3. So this is along OP. Next to find along PQ. Here P is 0 1, Q is 2 1. So in these 2 points y is 1 and dy equal to 0. So x limits are 0 to 2. So to find integral 0 to 2 plus I z square dz equal to integral x limits are 0 to 2, z square is x plus iy whole square, dz is dx plus I dy. So that equal to integral 0 to 2 x square minus y square plus 2ixy dx plus I dy. That equal to, then substitute y equal to 1 and dy equal to 0. We get integral 0 to 2 x square minus 1 plus 2ix dx. So integrating with respect to x, we get x cube by 3 minus x plus 2ix square by 2 with the limit 0 to 2. Then substitute upper limit is 2 and lower limit is 0. That equal to 8 by 3 minus 2 plus 4i. That equal to 2 by 3 plus 4i. This is the uh, integration value along PQ. Finally, we get the imaginary axis to I, and then horizontally to 2 plus I is integral 0 to 2 plus I z square dz equal to adding along OP and PQ, that equal to minus I by 3 plus 2 by 3 plus 4i, that is 2 plus 11i by 3. Next problem is evaluate integral 0 to 1 3x square plus 4xy plus ix square dz along y equal to x square. Solution is to evaluate integral 0 3x square plus 4xy plus ix square dz. And given equation is y equal to x square, which implies dy equal to 2x dx. So in this equation, it may be changed into x. That's why then substitute y equal to x square and dy equal to 2x dx. So this equation, it may be changed into x. Then we have to take the limits x equal to 0 to 1. 3x square plus 4x into y is x square plus ix square into dz. dz means dx plus I dy. So dx plus I into dy is 2x dx. That equal to integral 0 to 1 3x square plus 4x cube plus I into x square into dx into 1 plus 2ix. So that equal to multiply with 1 plus 2ix, we get integral 0 to 1 3x square plus 6ix cube plus 4x cube plus 8i x power 4 plus ix square minus 2x cube dx. So integrating with respect to x, then each term, first term is 3 into x square is x cube by 3 plus 6i into x power 4 by 4 plus 4 into x power 4 by 4 plus 8i into x power 5 by 5 plus I into x cube by 3 minus 2 into x power 4 by 4. So then substitute upper limit 1 and lower limit is 0. We get 3 by 2 plus 103i by 30. Next one is evaluate integral 0 to 3 plus I z square dz along the line y equal to x cube along the parabola x equal to 3y square. First, to solve this problem along the line y equal to x cube. So to evaluate integral 0 to 3 plus I z square dz equal to z square means x plus iy whole square and dz is dx plus I dy. So limits are 0 means 0 plus I0. So this is in the form of x plus iy. Here x0, y0, and also 3 plus I means x is 3, y is 1. So limits are 0, 0 to 3, 1. First, to find along the line y equal to x cube. That means dy equal to dx by 3, which implies dx equal to 3 into dy. Then the integration may be changed into x variable. So integral x limit, then we have to take an x limits 0 to 3 and they substitute y equal to x by 3 and dy equal to dx by 3. So x square minus y square means x square by 9 plus 2i into x square by 3 and multiple of dx into 1 plus I by 3. Next, multiple with 1 plus I by 3 with the x square minus x square by 9 plus 2i x square by 3. Then separate the integration with respect to x. We get x cube by 3 plus I by 3 into x cube by 3 whole cube minus 1 by 9 into x cube by 3 0 to 3 minus I by 27 x cube by 3 plus 2i by 3 x cube by 3 minus 2 by 9 x cube by 3. Then substitute the upper limit is 3 and while lower limit is 0. We get 6 plus 26i by 3. So this is the integration value along the line y equal to x cube. Next, the second one is along x equal to 3y square. So dx is 6y dy. So given integration, integral 0 to 3 1, z square means x plus iy whole square, dz is dx plus I dy. Then this equation may be changed into y. That is, then substitute x equal to 3y square and dx is 6y dy in the above integration. So we have to take in the y limits 0 to 1. X square means 3y square whole square, that is 9y square minus y square plus 6i y cube into 6y dy plus I dy. So dy is a common value. That's why 6y plus I into dy. So that equal to integral 0 to 1 9y power 4 minus y square plus 6i y cube into 6y plus I into dy. Next, multiple with 6y plus I. Then we get integral 0 to 1 54 y power 5 plus 9i y power 4 minus 6y cube minus 9y square plus 36i y power 4 minus 6y cube of dy. Then separate integration with respect to y and substitute with the limits 0 to 1. We get upper limit 1 and lower limit is 0. Finally, we get 12 by 2 plus 130 I by 15 equal to, after cancellation, 6 plus 26 I by 3. Next problem, evaluate integral 0 to 1 3x square plus 5y plus I into x square minus y square dz along y square equal to x. To evaluate integral 0 to 1 3x square plus 5y plus I into x square minus y square dz. The given curve is y square equal to x. So that means y equal to root x and dy equal to 1 by 2 root x dx. That equal to, then this integration may be changed into x variable. That's why then substitute y equal to root x and dy equal to 1 by 2 root x dx. So the limits are, we have to take in the limits, x limits 0 to 1, 3x square plus 5 root x plus I into x square minus x multiple of dx plus I by 2 root x into dx. That equal to 0 to 1, 3x square plus 5 root x plus ix square minus ix plus dx into 1 plus I by 2 root x. That equal integral 0 to 1, then multiple with 1 plus I by 2 root x, we get 3x square plus 3i by 2 into x power 3 by 2 plus 5 into x power 1 by 2 plus 5i by 2 plus ix square minus 1 by 2 x power 3 by 2 minus ix plus 1 by 2 x power 1 by 2 and dx. Then integrate with respect to x, we get 3 plus I is constant, x square integration is x cube by 3 with the limit 0 to 1 plus 3i minus 1 by 2 is a constant. Then x power 3 by 2 integration is x power 5 by 2 by 5 by 2. That means 2 by 5 into x power 5 by 2 with the limit 0 to 1 plus 5 plus 1 by 2 is 11 by 2 into x power 1 by 2 integration is x power 3 by 2 by 3 by 2. That means 2 by 3 into x power 3 by 2, 0 to 1 plus 5i by 2 into dx is x 0 to 1 minus I into x integration is x square by 2 with the limit 0 to 1. So first term is 3 plus I into 1 minus 0, 1 plus 3i minus 1 by 5 into 1 plus 11 by 3 into 1 plus 5i by 2 into 1 minus I into 1. So that equal to, finally we get 67 by 15 plus 44 by 15 into I, that equal to 67 plus 44 I by 15. This is one of the important problem in a line integral. Evaluate integral 0 to 1 plus I x minus y plus ix square dz along. First one is the straight line from z equal to 0 to z equal to 1 plus I. Second one is the real axis from z equal to 0 to z equal to 1, and then along the line parallel to imaginary axis from z equal to 1 to z equal to 1 plus I. Third one is along the imaginary axis from z equal to 0 to z equal to I, and then along a line parallel to real axis from z equal to I to z equal to 1 plus I. This is the problem. Solution is to evaluate integral 0 to 1 plus I x minus y plus ix square dz. Then dz is dx plus I dy. Limits 0 to 1 plus I means 0 plus I into 0. So x 0, y 0. 1 plus I means x is 1, y is 1. So 0, 0 to 1, 1. X minus y plus ix square into dx plus I dy. To find the integration, first along the straight line from z equal to 0 to z equal to 1 plus I. That means the points 0, 0 to points 1, 1. And in this straight line, then equation is y equal to x and dy equal to dx. So this equation may be changed into the variable x. Then substitute y equal to x and dy equal to dx. So integral. Then we have to change into the variable x. So we have to take in the limits, x limits 0 to 1. Integral 0 to 1 x minus y is x plus ix square into dx plus I into dy is dx. That equal to integral 0 to 1 ix square into 1 plus I into dx. That equal to I multiple of 1 plus I is a constant. So we write without integration, and multiple of x square integration is x cube by 3 with the limit 0 to 1. So that equal to I into 1 plus I by 3. Then substitute upper limit 1 and lower limit 0. We get 1 minus 0, 1. So that equal to 1. That equal to I plus I square by 3. I square is minus 1. So 1 minus I by 3. So this is the integration value along the straight line y equal to x. Second one is along the real axis from z equal to 0 to z equal to 1, and then along the line parallel to imaginary axis from z equal to 1 to z equal to 1 plus I. So in this figure, origin 0, 0, 2, that means along the real axis from z equal to 0. Z equal to 0 means origin to z equal to 1. Z equal to 1 means real axis. That means x equal to 1 and y equal to 0. And then, so this is the continuation of along the line parallel to imaginary axis. So parallel to y axis from z equal to 1. Z equal to 1 means 1 comma 0 to z equal to 1 plus I. That means the point is 1, 1. So we have to find the integration, integral 0 to 1 plus I x minus y plus ix square dz equal to, first to find along OA and adding along AB. So first to find the along OA, then we write the points O is 0, 0 and A is 1, 0. So in these 2 points y is 0, which implies dy equal to 0. We have taken the limits, x limits are 0 to 1. So this integration may be changed into x variable. Then we have to take in the x limits 0 to 1. After integration, we have to, the answer is 1 by 2 plus I by 3. So this is the integration value along OA. Next we have to find along AB. Next, to find along AB. So the points are A equal to 1, 0, B equal to 1, 1. So equation is x equal to 1 and dx equal to 0. We have to take in y limits are 0 to 1. So integral x minus y plus ix square into dx plus I dy. Then substitute x equal to 1 and dx equal to 0. This integration may be changed into the variable y. Then we have to take in the y limits are 0 to 1. That equal to integral 0 to 1 I minus iy minus 1 dy. Then integrate with respect to y and substitute the limits 0 to 1. Then we get I by 2 minus 1. So next, the second value is the real axis from z equal to 0 to z equal to 1, and then along the line parallel to imaginary axis from z equal to 1 to z equal to 1 plus I is next third one along OA plus along AB. So first along OA is then we have to get the answer is 1 by 2 plus I by 3 plus along AB is I by 2 minus 1. So final answer is 5I by 6 minus 1. Next third one is along the imaginary axis from z equal to 0 to z equal to I, and then along a line parallel to real axis from z equal to 1 to z equal to 1 plus I. So the integration value is integral 0 to 1 plus I x minus y plus ix square dz equal to, then we have to find along OC plus along CB. So see in this figure, from z equal to 0 to z equal to I means z equal to 0, that is origin 0 0, to z equal to I. Z equal to I means 0 comma 1. This is a imaginary axis means y axis, and along the line parallel to real axis, that means parallel to x axis, that is z equal to 1 2, that means z equal to 1 2 means 0 comma 1 2, z equal to 1 plus I, that is the point is 1 1. So we have to find the integration value, then first to find along OC and next we find along CB. Finally adding these two values we get the final integration. So first to find along OC. So points are O is 0 0 and C equal to 0 1. So in these 2 points the value is x equal to 0. Then which implies dx equal to 0. Y limits are 0 to 1. Then integral 0 to 0 to 1 plus I is x minus y plus ix square dz. Dz means dx plus I dy. So this integration may be changed into y variable. So integral 0, then we have to take in y limits 0 to 1. We integrate after we get minus I y square by 2 with the limit 0 to 1, that equal to minus I by 2. Next, to find along CB. So the points are C equal to 0 1 and B is 1 1. So the value is y equal to 1, and which implies dy equal to 0. X limits are 0 to 1. So to find the integration along CB is integral 0 to 1 plus I x minus y plus ix square dz is dx plus I dy.